Hi, I'm Nicole. In this video, I'm going to show you how to create, test, and deploy a full blockchain in just 30 minutes. At the end, you'll be able to release your blockchain into the wild, run a node for it, and interact with your logic using a simple provided UI. All you need is a very basic understanding of smart contract development, like just knowing what a signed transaction is. Specifically, we'll be making a proof of existence blockchain. This type of blockchain will help your users prove the existence of some files or some data somewhere at a particular timestamp. So for example, suppose Alice has a writing assignment due tonight, but Bob can only collect her paper in person next week. How can Alice prove to Bob that she did complete her assignment in time? Well, she can use a PoE blockchain. First, off-chain, she compresses and encrypts her file into its file digest, represented by this hash. And then she can send a transaction to the PoE blockchain before midnight. This transaction just needs to associate the file hash to her identity and the block number that she sent it in. Thus, she has claimed this file. And subsequently, to verify, Bob can compute the digest of Alice's same assignment on his own and look up the same hash on the PoE blockchain. And then he can verify that Alice has indeed marked it as her own assignment before midnight. To make our lives easier, we'll use a blockchain framework called Substrate, which is an open source and extensible kit for you to build blockchains. Substrate already provides a lot of the core components of a blockchain, such as the database layer, the networking layer, a transaction queue, and various consensus mechanisms, all provided out of the box. For this workshop, we'll be modifying just the logic layer of the blockchain called the runtime. Now, since Substrate is currently written in Rust, we'll be working in Rust. But if you're new to Rust, don't worry. We'll be stepping through the Substrate boilerplate code in great detail. And you actually won't need to install any of the Rust or Substrate dependencies, as we'll be using Substrate Playground, which is an online IDE with pre-compiled boilerplate Substrate code. This helps us skip all of the setup, and it really speeds up your development. And within Substrate, we'll be implementing three things. First, we'll define a storage variable called proof to store information on who claimed the digest hash, as well as the block number they claimed it in. Next, we'll create a state transition function called claim for your blockchain, which will let your users send a claim transaction to write to the storage variable. And lastly, upon a successful transaction, we want the blockchain to emit an event called claim created. Now, let's head over to the online IDE at playground.substrate.dev and get ourselves oriented. First, you'll notice that the file directory already includes some boilerplate code for you. There's a front-end template and the boilerplate for the node. Let's step into the node, inside runtime, source, and find a file called template.rs. This is the starting development interface for Substrate. And because this template is already pre-compiled by this IDE, let's just start the node to see what happens. Great, so out of the box, you can already see that you have a working default blockchain. But that's boring. So now let's add our own runtime logic for the PoE, just to change things up. Within this template, first we'll want to create a storage variable to store who and when someone claimed a hash in the on-chain state. Let's look for a code snippet that says declare storage. Let me explain what this default code snippet here does. Declare storage with the exclamation mark at the end is a Rust macro. If you're new to Rust, Rust macros basically expand the code that you write inside its scope here into more code with more functionality. In this case, declare storage expands your variable declarations inside here into more functionality around those items. What functionality? Well, this macro looks to the next line for more instructions. Now, this line may look confusing because it's actually a custom non-Rust specific expression, as it tells the macro the following things. Trait store means please create a trait, a new trait called store, which is a trait that will associate the inner storage items, which we'll define later, to this module, which happens to be bound with a trait called trait. So module is actually defined below in another macro called declare module, where you'll write your actual blockchain runtime logic. Let's not worry about that for now, because all this snippet does is associate your storage variables here with your eventual runtime logic. Next, template module is the actual name of this module you're building. We can rename it to, say, proof of existence module, but we'll just leave it alone for now. And as template module just tells the macro to tie the variables that you create in here to this module later on. So for example, if you create a variable in here called foo, this allows you to later be able to do something like template module foo in order to invoke the variable. Now, behind the scenes, this declare storage macro does a lot of other stuff, like implementing free getter functions on your storage variables. It resolves various configurations and dependencies. It builds storage traits and functions, and it even handles fancier things. You're actually able to set up the state of your Genesis block using this macro. So it's very powerful. Now, let's create a custom variable to store our proof of existence claims. We'll need to use a Substrate data type called a storage map. In Substrate development, there are default storage types that are written on top of Rust storage primitives that you can use. Let's examine what storage map actually looks like within its documentation. Great. So you can see it's implemented as a storage map trait in an external crate called frame support, which is something that we'll actually need to import into our code. If you scroll to the very top, you'll notice that the external crate frame support is already implemented. So all we need to do is add storage map to be able to use this data type. Now, declaring the variables themselves in Substrate is similar to declaring fields in a struct. So here we can delete some of the default code. Let's create a storage map called proof, where the key is the file hash, and the value is going to be a tuple of who and when a particular file hash was claimed. Now, as you can see, the key is a vector of unsigned 8-bit integers, which is how Rust handles hexadecimals hashes. And to get account ID and block number, you can look to the system module in Substrate, which out of the box provides you with some predefined core data types, like account ID and block number. System functionality is already imported for you in this line, where we pedantically define a new trait called trait that inherits from system trait. And now we can access our core data types with T account ID and T block number. Now we're ready to write the on-chain logic to let users create and revoke claims to the blockchain. Go to the declare module macro, and here you see another Rust macro that makes creating state transition functions on the blockchain easier for you. Specifically, this macro creates callable functions that you want to expose in your runtime module. This macro takes in this header. And the macro roughly interprets this header to mean create a public struct module with type trait, which if you remember actually just inherits from system trait. And this again gives you all of the core data types and other things out of the box. And also create an enum called call, which behind the scenes will turn every function that you create inside the module into a callable thing on the blockchain. And finally, where origin T origin just aliases T origin, so you don't have to type this all the time. And finally, where origin torigin just aliases torigin, which you get from the systems module, so you don't have to type this snippet all the time within your code. Let's create a function that allows users to claim ownership of unclaimed proofs. Let's first create the function signature. Function claim takes in origin and a proof of vec u8s and returns dispatchable result. The callable functions you create in Substrate always need to return a result, specifically a dispatch result. Dispatch result is a struct that either assures your transaction successfully executed and it'll return an OK, or something went wrong and it'll return an error. And the first parameter to every callable function in Substrate must always be origin. An origin is a type that denotes where the transaction came from. Next, let's verify that the incoming transaction is signed and store who the caller of this function is. So let the sender equals ensure signed, which is a special function, put in origin. So let sender equals ensure signed, and we're ensuring that the origin is signed. Ensure signed is a free function that you get from the system module. It checks if the transaction is signed, and if it fails, it errors out and returns an error for the dispatch result. And if it succeeds, it'll return the sender address that's now being saved in the sender variable. Next, let's verify that the specified proof has not yet been claimed, and if it has, we want to error out with a standard message. So let's just ensure that within the storage map proofs, there exists a hash key and pass in a reference to the proof hash. So this ensure macro will exit a function early with error if the conditions are not satisfied. And you'll notice here there is special syntax for accessing storage variables that we've previously declared from inside this declare module macro. And that syntax here is proofs : open bracket t close bracket. The brackets in Rust is called a turbofish, and it specifies the specific trait that the storage item must have implemented. And for us, that's something that we have already previously done in declare storage. Next, let's get the current block number. So let's type let the current block, and let's reach into the system module to call the block number function. Now the system module has this function ready for you to use to retrieve the current block number. And if you notice, the syntax for reaching into other modules inside Substrate is slightly different in that it's nested inside of a turbofish. Finally, we want to store the proof in the storage map. So let's do proofs insert hash, pass in a reference to proof, with a tuple containing the values sender address and the current block number. And finally, if our transaction has proceeded to this step without erroring out, let's return a OK to the dispatch result. On to the last step. We want to dispatch an event upon a successful claim transaction. So let's go to the declare event macro. This macro takes in the following header, which just tells it to create a publicly accessible enum called event, which also happens to implement the trait of our current module. Now we want events to emit when a proof has been claimed. And we want the emitted event to include both the proof digest and the account ID or the address of the person who claimed it in the first place. So let's declare an event emitting function in here called claim created, which takes in the parameters account ID and a vector of u8, which is the proof. Now this snippet here helps the declare event macro actually recognize the account ID that we're typing here. Because remember, within this declaration, we're still within our current custom module, and account ID is provided by a separate module called system. Now to invoke this function and to emit the event, let's go back to our claim function, and let's emit the event at the very end, right after writing to state and right before returning the OK. And the custom syntax here, and you'll just have to remember this, looks like this. Self deposit event, raw claim created, and we want to pass in the sender and the proof. So that gets logged in the event as well. And that's it. So at this point, let's go ahead and compile our code to resolve any potential issues or dependencies. So go to Substrate, compile node. And we're getting a couple of issues here. I have a typo here. And it looks like we'll need to import the type vec. And this ensure macro. Great. So let's resolve our issues here. Ooh. Fix the typo. And then up here, let's go ahead and import more of our dependencies. To get access to the data type vector, we'll need to do use from a crate called spstd vec. And all of this information you can find in the Substrate documentation. And then up here, we'll want to import our ensure macro. And that should solve things. Let's compile it again. And once everything compiles, it should look something like this in the terminal. And finally, let's test our code just to be sure everything works. Scroll down in the template file, and you will see a separate module called tests that has been set up for you. What's happening here is that we're constructing a mock runtime, and everything is going to run in this module called test. As you can see here, the trait for this module that you've just built is being implemented for test. And you can see the basic setup of each unit test here, and it's usually preceded with this expression. Let's delete the boilerplate code and create a new test called it lets users make claims. In this test, we want to call the claim function on a specific hash, and then we just want to assert that the hash has indeed been claimed. So first, let's go ahead and create a hash of any arbitrary vector. So now we can assert OK, indicating that we expect the claim transaction is going to return a dispatch result of OK, that calling the claim function on template module with a signed origin address of 1 and with the hash is going to be a successful call. And here we have to clone the hash since the claim function will otherwise consume this variable. And note here, by default, within this test module, the block number is a U64 that will always default to 1. Next, we'll want to assert that the proof's storage map indeed has this key value pair. And to do that, we'll actually need a way to retrieve values from inside the proof's storage map. So at this point, let's go back up to the declare storage macro and add a line that tells the macro to generate free getter functions on proofs. And the syntax is just get proof. Coming back to the test, let's now assert that the value of this hash in proofs is indeed a tuple of the address 1 that we signed the claim transaction with and has block number 1. Great, you're now ready to run the test. So let's step into the directory that contains the cargo file at the level that we're currently working with and simply do cargo test and give it a minute. There, so our template tests it lets users make claims has passed. We're now ready to build and deploy our blockchain. Let's recompile our node first, since we changed the code template. After your node is compiled, let's go ahead and start your node. And then let's open up Polkadot app, which is a free frontend for Substrate that you get out of the box. As you can see, your custom blockchain is now up and running and producing blocks. Okay, now we're ready to send a transaction claiming a particular proof to the blockchain. So on Substrate, these external user transactions are actually called extrinsics. Let's head over to that tab. And you want to make sure from the account Alice, let's select the template module we just created, invoking the claim transaction. And let's claim a file digest of 1111. Submit the transaction, making sure to sign your transaction. Great, so that worked. Next, let's verify that the blockchain state has actually changed. So heading over to the storage tab, let's now look up the hash 1111. And there we see that it was claimed at a particular block time. And just to be sure, let's check a file digest that we haven't claimed yet, so 1110. And there you see it doesn't actually have a block number. Now, the account ID field of the tuple value will always have some pre-existing data in it, but all we need to check is that this was never claimed at a particular block number. And that's it. You now have a fully functioning blockchain where you've defined custom storage variables to store on-chain state, you've created a custom state transition function for your blockchain, and finally, you deployed a node for it and now have successfully interacted with your chain. If you're interested to learn more, visit our dev hub at substrate.dev and join our community chat in Riot.